फरीदा चार गवाया हंड कै चार गवाया सम लेखा रब मंगेसिया तू आहूं केरे कम Freed men lose the hours of day in wandering and the hours of night in sleep. God will call for your account and ask you the purpose for which you came to this world. Unit 4 Chemical Bonding and Molecular Structure by Amrik Singh, PGT Chemistry. Chemical bond, the attractive force which hold various constituents, that is atoms, ions, together in different chemical species is called a chemical bond. For example, oxygen atom in oxygen molecule are shown, both are attracting to one another. This represents a chemical bond. Now two questions arise. Why do atoms combine? Why are only certain combination of are possible? Why O2 is formed, not O4? Why are do atom combine? Why oxygen atom don't like to remain in isolated state? Why they combine? The answer is stability. Every system tends to be more stable. Stability can be gained by the loss of energy. When a chemical bond is formed, energy is lost, which is the main cause of chemical bonding. Octet rule. The second question is answered by why certain combinations are possible, that is by octet rule. Kossel and Lewis in 1916 developed an important theory of chemical combination between atoms known as electronic theory of chemical bonding. According to this theory, atom can combine either by transfer of valence electron from one atom to another or by sharing of valence electron in order to have an octet in their valence shells. This is known as octet rule. All the atoms tends to have 8 electrons in their valence shells, either by sharing or by complete transfer, accepting or losing the electrons. This statement is known as octet rule. Lewis symbol. G. N. Lewis, an American chemist, introduced simple notation to represent valence electron in an atom. These notations are called Lewis symbols, are shown below. For example, lithium 1 dot, beryllium 2 dot, boron 3 dot. The dots are representing the valence electron of these atoms. Significance of Lewis symbol. The number of dots around the symbol represent the number of valence electron. This number of valence electron help to calculate the common or group valence of the element. Note, Kossel in relation to chemical bonding drew attention to the following facts. The formation of a negative ion from a halogen atom and a positive ion from an alkali atom is associated with gain and loss of electron by respective atoms. The negative and positive ion thus formed attain stable noble gas electronic configurations. The negative and positive ion are stabilized by electrostatic attraction. Ionic bond. The bond formed as a result of electrostatic attraction between positive and negative ion was termed as electrovlaent or ionic bond. The formation of NaCl from sodium and chlorine and formation of CF2 may be shown as, first of all, NaCl. Na has outer electron Ne3s1 configuration, loses one and achieves the noble gas configuration Na positive E negative. Similarly, this electron which is lost by the Na is gained by the Cl. And Ne3s23, after achieving one electron, it get a noble gas configuration, that is of argon 3s23p6. Na positive will be attracted by Cl negative and NaCl will form. This electrostatic force of attraction between Na positive and Cl negative is called ionic bond. And similar the case for calcium have two valence electrons. It loses two electron, forms Ca2 positive and 2E negative. argon noble gas and achieves the noble gas configuration. Fluorine can accept one electron and achieves the noble gas configuration of neon. Ca2 positive will require two fluorine atoms and CaF2 will be formed. Condition for the formation of the ionic bond, very important. Ionization energy of one atom should be small. Electron affinity of the other atom should be high. These are the two conditions for the formation of ionic bond. Electrovalence. The electrovalence is thus equal to the number of unit charge on the ion. The calcium is assigned a positive electrovalence of 2, while chlorine a negative electrovalence of 1. Electrovalence V is the total number of electron gained or lost by an atom is its electrovalence. Covalent bond. The bond which is formed by the mutual sharing of electron is called a covalent bond. Formation, for example, formation of Cl2. As shown here, chlorine have 7 electron in its valence electron, both the chlorine and they share 2 electron and completes their octet as shown in the diagram. In this a Cl2 is formed. Covalent bond, mutual sharing, 1 electron from each chlorine atom. Note, when two atoms share one electron pair, they are said to join by single covalent bond. If two atoms share two pairs of electrons, the covalent bond between them is called a double bond. When combining atoms share three electron pair, as in case of nitrogen atom in N2 molecule and the two carbon atom in the ethene molecule, a triple bond is formed. Two atom in ethine molecule. Formal charge will be equal to total number of valence electron in the free atom minus total number of non-bonding electron minus 1 by 2 total number of bonding electron. Generally, the lowest energy structure is 1 with the smallest formal charges on the atoms. The formal charge is a factor based on the pure covalent view of the bonding in which electron pair are equally shared equally by the neighboring atoms. Limitations of the octet rule. It applies to the second period element of the periodic table. There are three types of exceptions to the octet rule. The incomplete octet of the central atom LiCl, BS2, BCl3, they don't have the 8 electrons. Odd electron molecule, they also don't have the 8 electrons, and expanded octet, third one is SF6, PCl5, S2, SO4. They have more than 8 electrons on the central atoms. Other drawbacks of the octet theory, first one is it is clear that octet rule is based on the chemical inertness of the noble gases. However, some noble gases also combine with oxygen and fluorine to form a number of compounds like XZF, KRF, XZOF2, etc. This theory does not account for the shape of molecule. It does not explain the relative stability of molecules. Lattice enthalpy. The lattice enthalpy of the ionic solid is defined as the energy required to completely separate 1 mole of solid ionic compound into its gaseous constituents. For example, lattice enthalpy of NaCl is 788 kJ per mole. Lattice enthalpy is directly proportional to the charge of atoms, inversely proportional to the size, and directly proportional to the stability of ionic solid. Bond length is defined as the equilibrium distance between the nuclei of two bonded atoms in a molecule. And bond angle, it is defined as the angle between the orbitals containing a bonding electron pair around the central atom in a molecule oblique complex ion. Bond angle is expressed in degree. Bond enthalpy, it is defined as the amount of energy required to break 1 mole of bond of particular type between two atoms in a gaseous state. The unit of bond enthalpy is kilojoule per mole. For example, HS bond enthalpy in hydrogen molecule is 435.8 kilojoule per mole. Bond order. In the Levy's description of covalent bond, the bond order is given by the number of bonds between two atoms in a molecule. Isoelectronic species and ions have identical bond orders. For example, F2O2 negative have bond order of 1 and 2CONO positive had bond order of 3. Resonating structure. According to concept of resonance, whenever a single structure cannot describe a molecule accurately, a number of structures with similar energy, position of nuclei, bonding and non-bonding pair of electrons describe the molecule accurately. Such structures are called canonical structures. While the actual structure lies in between, the canonical structure is called a resonance hybrid. Resonance hybrid is represented by a double-headed arrow. Thus, for O3, the two structures shown above constitute the canonical structures or resonating structure, and their hybrid, that is third structure, represent the O3 more accurately. This is also called resonating hybrid, and the resonance of O3 in O3 will be shown in the next slide. Yes, O3, you can see the resonance. First two is the canonical structure and third one is the resonance hybrid. Similarly, the resonance for CO3 2 negative and similar for the CO2 molecule is the case. In general, it may be noted resonance stabilizes a molecule as energy of resonance hybrid is less than the energy of any single canonical structure. Resonance averages the bond characteristics as a whole. Thus, the energy of O3 resonance hybrid is lower than that of other two canonical forms, 1 and 2. It should be noted that canonical forms have a no real existence. The molecule does not exist for a certain fraction of time in one canonical form and for other fraction of time in other canonical form. There is no such equilibrium between the canonical form as we have between tautomeric form in tautomerism. We will discuss later on this topic. The molecule as such has a single structure which is resonance hybrid of the canonical form and which cannot as such be depicted by a single Lewis structure. Polarity of bond, the existence of 100% ionic or covalent bond represent an ideal situation. In reality, no bond or a compound is either completely covalent or ionic. Even in case of covalent bond between two hydrogen atoms, there is some ionic character. When covalent bond is formed between two similar atoms, for example H2O2, Cl2, N2 or F2, the shared pair of electron is equally attracted by two atoms. As a result, electron pair is situated electron between the two identical nuclei. The bond so formed is called non-polar covalent bond. Contrary to this, in case of heteronuclear molecule like HF, the shared pair between two atoms get displaced more toward fluorine since the electronegativity of fluorine is far greater than that of hydrogen, as we studied this in chapter number 3, periodic properties. The resultant covalent bond is a polar covalent bond. जो हमरी बिद होती मेरे सतगुरा साबिद तुम हर जानो आपे हम रुलते फिरते कोई बात ना पूछता गुर सतगुर संग कीरे हम थापे. My condition, O my true Guru, that condition, O Lord, is known only to you. I was rolling around in the dirt and no one cared for me at all. In the company of Guru, the true Guru, I, the worm, have been raised up and exalted. Thank you. By Amrik Singh, PGT Chemistry, for watching.